determining the formula for a circle just from the circle's graph. And that form is called the standard form. Now, most of the time in math, or a lot of the times in math, you start with some sort of equation, you try to answer it, like find its zeros or graph it, find its domain and range. So you start with the equation. But here we are starting with a graph, and it's a well-scaled graph here, you can see. And so we're actually going to try to pull back from the graph to fill in the numbers for this standard form, what they call the standard form. Now, I didn't write all this down, but H and K are the coordinates of the center. H is the X coordinate of the center. K is the Y coordinate of the center. Then the radius, this is written in the form R squared because really this whole thing was derived from the Pythagorean theorem. You remember A squared plus B squared equals C squared for a right triangle where C is the hypotenuse and A and B are the lengths of the shorter legs. This is just that in a different format because you can have little right triangles in here creating all these distances. So again, this is called the standard form. Now, one thing that's clear is the center of the circle is at -3 and 3. In other words, if you move 3 to the left, that's -3. If you move up 3. So the coordinates of the center are -3 to 3. I mean, -3 and 3, excuse me. X coordinate -3, Y coordinate 3. Now, the radius, you see, so we already have half the problem done. We know that we can put -3 in there and get an X plus 3 quantity squared. We could put +3 in there and get Y minus 3 quantity squared. But we don't know what R is. Now, we can look here, though, and get a good idea. Okay, if you count up 1, 2, 3, now you have something a little bit more than 3 here. It looks like a little bit more than 3.5. But the point here is that we can't conclusively say what R is. We can only state that R is between 3 and 4. So you see, that means we're going to have to find R by some other means. We already know the center just by eyeballing the graph, and we know that -3 will go right there where the H is, and 3 will go right where the K is. But we very well can't put R as a number between 3 and 4 and make this equation work. So what we have to do is use what we call the intercepts to solve this problem. Now, notice this problem is designed to work out nicely. You have a y-intercept of 0, 5 here, 0, 1, -1, 0 for your x-intercept, and -5, 0 for your other x-intercept. Now, y'all, you may know this, but another name for the y-axis is x equals 0, right? X is equal to 0 anywhere along the y-axis because to the right of y, x is positive. To the left of y, x is negative. So x equals 0 is another name for the y-axis. That's why we set x equal to 0 to find these coordinates. So again, the coordinates for the y-intercepts would be 0, 5, 0, 1. Similarly for the x-axis, another name for the x-axis is y equals 0. All right, so this would be -1, 0 and -5, 0. So those are the 4 intercepts. Now let's think about that as we go to the next slide here. All right, now I've written down all 4 of the intercepts, but it turns out you really only need one of them to solve this equation, to figure out what R is. Again, R is what we're trying to determine. We already know the center, right? Now I just arbitrarily picked a point at 0, 5. You could have picked any of them, and that's a good thing for you to check if you want, but I just picked 0, 5. I wrote down all 4 of them, but it turns out we only need one. So look what happens here. If you put the 0 right there where the x is, and the 5 right here where the y is, you're going to get 3 squared plus 4 squared, which is 13. So that tells you that r squared has to be 13, and the radius itself is √13. Okay. Now, so that means that, and notice that the 3 being between √13 and 4 is consistent with what the graph originally looked like. That's a number between 3 and 4. And if you remember, we saw that the radius would be a number between 3 and 4, right? Now we can move this direction too, the very same thing. A number between 3 and 4, a number between 3 and 4 down here, and same over here. So all kinds of information is given to us from the graph to determine the equation. So let's go back here. So this would be this is the answer to the question. Okay, the green dot answer here is your standard form for your circle is x plus 3. Notice that -3 was the coordinate of the x coordinate, but the form of the equation is x minus. So this becomes a plus, this becomes a minus, and then that's it. Now but I want to show you just one more aspect of the value of having an equation. Let's move to this slide right here. Now, I'm just going to pick on the number 2, folks. If you look at x equals -2, you can tell the graph, the circle is maybe right around -1 or maybe -1/2 or something like that at -2. And then also the circle being what it is, it has another point at -2. And that would be around 6 and whatever, maybe 1/2, not sure. Okay, so you got a number that's between 0 and -1 down here, associated with, that's the y coordinate at x equals -2, but you also have a y coordinate between 6 and 7. Now notice if you substitute -2 in right here for x, yeah, the y doesn't get changed. You're just substituting -2 in for x. It results in this part right here. What we have right here is this part right here is just 1. So you see, you're going to get y -3 when you take the square root of this, okay, is equal to this result right here. You take your plus and minus square roots. Yeah, that was a little confusing the way I said that. If you put -2 right here, that gives you a 1. So when you subtract that from 13, you get 12, right? Again, if you put -2 here, when you add it to 3 and square it, you get 1. Now you subtract that 1 from 13 to get 12, all right? And so when you take the plus and minus square roots, you get y -3 is equal plus or minus root 12. And so this is the result. Now these are the y coordinates corresponding to x equals -2 right here, right? Now root 12 is a number between 3 and 4, right? So 3 minus a number between 3 and 4 would be about right here. And 3 plus a number between 3 and 4 would be somewhere in there. We don't know the exact values. But anyway, hope you guys enjoyed that. I hope it helped. Again, the spirit of this was to work from the graph to the equation and also answer a question. All right, good night.